Doctor, I don't think we're gonna be able to save him. He's doomed.
Not yet. Prepare to bring in the nanotechnology.
The three wise science guys.
Three.
The three wise science guys.
Three wise science guys.
The three wise science guys.
Nanotechnology is more than just science fiction. In fact, it is anything conducted at the nanoscale, about 1 to 100 nanometers.
This isn't like the quantum level that can't be accessed. This is a real measurement. It's just super small.
Physicist Richard Feynman is considered to be the father of nanotechnology. He put forth the basic concepts behind it in 1956, years before the actual term was coined.
It wasn't until the invention of the scanning tunneling microscope in 1981 that modern nanotechnology truly began. Now Alex, Sam, let's dive deeper into this as we
Consider the following.
Now, let's take a standard ruler as I place it on the table of science.
Alex, that's just a normal table.
Anything is science if I say it is. Now, let's take a centimeter as we go smaller, 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 and smaller until we reach 1 times 10 to the negative 9th meters, or 1 nanometer. Now you truly know how small this is.
This definition of nanotechnology, anything done on the nanoscale, indicates that human beings have been utilizing nanotechnology for hundreds of years.
That's insane!
The first form it took appears to be stained glass windows, which date back all the way to the 10th century. The bright and vibrant designs of the windows are able to exist because of nanotechnology. The intense heat coupled with the glass and paint results in the creation of colored nanoparticles. Of course, the medieval artisans at this time never knew what they were doing was nanotechnology. However, that doesn't change the fact that the process still fits with the definition: manipulation of the nanoscale.
This may seem strange. When most people picture nanotechnology, they probably imagine a bunch of electronics and tiny nano-sized drones. But it's important to understand that nanotechnology isn't anything specific. It's a whole area of study. Chemistry isn't just the periodic table and beaker-related lab experiments. It's the study of change, which includes a whole bunch of material. Just like that, nanotechnology includes any study and manipulation of objects on the nanoscale, which is more than just the super scientific stuff.
Alex, wake up.
So we've got the definition, scope, and the first appearance of nanotechnology. But how is it actually being used today? Well, it's in more ways than you think. One highly unpredictable application is in the clothing industry. Many companies are utilizing nanoparticle coatings on the outer layers of their fabrics to make them waterproof or UV protected. For example, silica nanoparticles infused into the weaves of your clothes can make them hydrophobic and repel water.
So you're saying that I could have these things on my body right now? Get them off!
On the contrary, mysterious voice, the nanotech within your clothing is actually enhancing your life. For another example, nanoparticles of silver have the handy ability of destroying harmful bacteria and fungi, keeping you squeaky clean and unlikely to contract harmful bacteria infections from your sweat.
As well, the medical applications of modern-day nanotechnology are very promising. Imagine tiny robots roaming through your bloodstream, maximizing the ways in which medicine is released to cure diseases, most efficiently and effectively.
As you can see, the nanoparticles, armed with the highly effective cancer drug, DOX, can specify the types of cells exposed to it. Typically, when this drug is introduced into the body, healthy cells are killed alongside the cancer cells, which is bad.
Yeah, pretty bad, Sam.
The nanoparticles are programmed to look for oncoproteins present on cancer cells and tumor clusters, rather than bombard the somatic cells with the harmful medicine. This specificity is the key to the increased efficiency of drug release in cancer patients.
English, Sam.
These tiny artificial robotic particles can sift out cancer cells and
Destroy them.
Let's finish this off here with an idea of the bigger picture.
Of course, not everything with nanotechnology is happy and fun.
A long-term problem associated with it would be the increase in the number of nanopollutants in the world. Since they're so small and can get everywhere, they could potentially cause a huge long-term problem.
Scientists today are still in debate about this. However, without a doubt, nanotechnology is the future.
Now, if you'll excuse us, we've got some nanoscience to do. See ya!